Okay, let's take a look at question 1b. And it's actually got a space for the answer here, but the space is not really what I want. I want a slightly larger space so I can really tease this out. And it says, what values of x is f? What values of x is f, that's the function, a decreasing function. And we're going to justify our answer. So let's write out the actual question first. So we've got f of x is equal to 8 plus 3x plus x squared minus x cubed on 3. Let's find the differential function. We have to do that because what we're wanting to find are the turning points, because this is some sort of a cubic. And if we know the cubic functions, in other words, it's going to look something, and I'm just going to spitball here, it's going to look something like this. And if we know the x value of the turning point and the x value of the turning point, then we can start to say where it's going to be increasing or decreasing. So that's what we're after. So let's go ahead and do that. So this is going to equal 3 plus 2x minus, this is going to be 3x to the 3 on 3. I'll just tidy that up a little bit. 2x already, minus, and 3 divided by 3, of course, leaves with an x. This is going to be x cubed. Wait. What have I done? Sorry, this is x squared. I didn't put a square in there. That should be a squared. So it should be x squared there. So, and it's not really easy to see, but it does say 3 plus 2x minus x squared. That's what we got. So we're going to make this equal to 0 now. And by making it equal to 0, what I'm going to do is I'm going to find the turning points. I'm going to find the x value of this thing here and the x value of this thing here. And I've got no idea really how this sits in relation to some sort of axes. We do not know that. So let's try and work out where that could be. But we do know it's a negative. We do know it's a negative cubic. So let's go ahead and do this now. So first thing I'm actually going to do is I actually want everything to be positive. It just makes life easier. So I'm just going to say that 0 is equal to negative. And I'm just going to say this is going to be x squared minus 2x minus 3. And now we're going to go ahead. So it's a negative cubic. In this case, this will be a negative parabola now. So it's going to be negative, and I'm going to have two sets of brackets, and I'm going to solve for x. So factors of 3 are 1 and 3. So I've got an x and I've got an x. Signs are different. The biggest number of the two is going to be negative 1 and 3. So 3 is going to be negative and 1 is going to be positive. So therefore, either x is equal to negative 1 or x is equal to 3. So if I was to draw that out as like, if I was going to draw this graph here, if I was going to draw that graph there, this here is going to be f of x, f prime x, sorry. Or in other words, it's the gradient. We could write m there if you wanted. This here is going to be a negative 1. Here it is, a negative 1. And over here is going to be a positive 3. And it's a negative graph, so it's going to head round and look something like this. And head down through there. And that's where it is. So we know that if this is the case, what's going to happen is we've found 2 points. These points are going to be relative to the turning points of this thing here. So this point here, it means, is going to be our negative 1, and this point here is going to be our positive 3. Now I'm going to superimpose another graph. So it's going to look something like this, and we don't know exactly. But it's going to look something like that. So we're going to say negative cubic. This is going to be max turning point. And over here, this is going to be the minimum. In fact, we'll probably draw it a little bit better, but this is minimum. Turning point. All right. So that's what this thing roughly looks like. Now we need to be able to show that they're maximum and a minimum. So we've got a negative and a 3 here, a negative 1 and a 3. So what we want to do is to actually show that to be the case. So, well, first of all, if we can show that that's a minimum, and this is to be a maximum, then because it's negative, it must be decreasing here, increasing here, and then decreasing again here. So let's go ahead and work that out. So let's prove that this, in fact, is a minimum. So I'm going to say second differential test to ascertain nature of turning points. So here we go. F prime x is equal to, and we've got 3 plus 2x minus x squared. F double prime x, therefore, is equal to 2 minus 2x. So substitute in negative 1. So f double prime negative 1 is equal to 2 times negative 2. Oops, got 2 plus, yes? It's going to be 2 minus 2 times negative 1. Now, 2 minus, what have we got here? Negative 2 times negative 1 is going to be positive 2. And 2 and positive 2 is going to equal 4. So we can say, because f double prime negative 1 is greater than 0, therefore, turning point at x equals negative 1 must be a minimum. Okay, so that's the first point. Let's create a little bit of space here. Now let's do the same again for the other one. So I'm going to put sub negative 1, so sub plus 3 into f double dash of x. So here it is, f double dash of 3 is equal to 2 minus 2 times 3. 2 minus 6 is going to equal negative 4. And therefore we can say, therefore, because f double dash 4 is less than 0, turning point at x is equal to 3. Oh, wait, that's a 3, sorry. Just copying a 4 into there. We want a 3, don't we? Because it's the 3 here. Must be a maximum. Now, we want to be able to say, okay, negative cubic with min at x equals negative 1 and max at x equals 3 must be decreasing where, or you could say such that, yeah, such that. I think such that's a pretty bad thing to say here. Such that let's think the best way of saying this. X is going to have to be greater, less than negative 1, or x is going to be greater than 3. And I'm going to draw a little graph here, like this. So here is my 3. Here is my negative 1. And we can say decreasing, decreasing. And hopefully that would do it for them. Now that's with an excellence, apparently. So that's really what you want to say. I think if you can include all of that, you're going to end up with your excellence. So hopefully that all makes sense.